What is up, guys? So today, Jogamin, we're gonna learn this is part 2 of vectors in Calc 3. So we ended off right here. Now, um, so basically, we're gonna should I really let's do a problem, quick little problem before we get to the multiplication stuff. And so, by the way, addition of vectors. Say this is v right here, right? Um, v plus u can be represented by, well, u can be right here, like right at the tip or the terminal point. Its initial point, the initial point of u will start at the terminal point of v, and they will add, and then this new one right here, this new vector from the origin can be u vector plus v vector, and you can notice how this forms a triangle. So we're going to be using that type of logic to solve an equation. So suppose got a dot right here. You get this is v vector, and this is u vector, and yeah, this is fine. Suppose there's a vector down here. Let's call it C. This is bad. And then we have two congruent sides that are also vectors. Yeah. And we'll call it D. And we'll call this corner Q, T, R on this side, and S in the middle. So the problem asks express, yeah, that's just the word for express, C and D in terms of A and B, or not A and B, B and U. So where do we even start? So like I said earlier, hold on. Okay, so we can see that from this triangle alone, C right here, from here, and then D on its terminal end goes to R, which is at the length or terminal point of U vector. So by the law of adding vectors, C vector plus D vector equals U vector. So that's one equation. So you'll have C and D represented in terms of V and U, but we have a C and D in here, which we need a substitute for other stuff that are related to U and V. So look at this side. You drink water. Notice this congruent D vector, basically the same D vector, at the terminal point of V vector, and it reaches to the vector terminal point of C. So you can write that V vector plus D vector equals C vector. Now subbing all this in, or alternatively, you can also say that v vector plus 2d vector equals u vector, which you could have gotten just by subbing in C for this, or just by looking at the diagram itself with the same logic, but I digress. Anyways, with this, let me see how much time I got. Okay. With this, we solve for d, which is kind of obvious. U minus v vector over 2 equals d vector. Sub it back into here. Well, actually, sub back into here. You get v vector minus v vector plus u vector minus v vector over 2. And simple math, that's u vector plus v vector over 2 equals c vector. And that makes sense because, well, I mean, when you can technically say that c is the midpoint between the length, the line segment of u vector and v vector, which is true. It is the c vector is actually in the middle, so this is what this equation is describing, but I digress. Let's get into some real stuff now. Hold on. Need a pause. Alright, so let me tell you another property of vectors is that, let's say you're on a coordinate grid, you have a vector here, and say you had a vector here, or maybe even a vector here, or extend it here like a vector here. You can always move these vectors, any one of these vectors, anywhere, as long as they're consistent in their length and their direction and pointing at. So let's call this a vector, and I can move this a vector to here, a vector prime. Let's say it's translated right, but it's technically the same. This is the addition. This, I'm not gonna comment on what this is right now, but basically, if I want to do an operation on this vector, on these two vectors, let's call it B, I can move this vector to connect tip to I mean, initial point to initial point. So I can do accurate or meaningful operations where I'll show you later. Or, alternatively, I can move this vector to the origin where A is at, and well, yeah, and this is it. And same goes with this. I can move this vector right here to over here. It's called the C vector. I can move the C vector to the tip, the terminal point of A. So put it here, and say this, and this would be C plus dA vector, or whatever operation I want to do on those vectors. So why this is important is I'm gonna teach you dot product. So u vector dot. In vectors there's two types of multiplications, and I'll show you. I hope to show you both. Probably not. Actually, I'll do the practice problem next video, maybe. Anyways, this is equal to, formally, it'd be equal to the, oh crap, wrong. To the magnitude of both vectors multiplying each other times cosine, and this theta refers to, like again I showed you, if I had two vectors like this, I could not get this angle theta unless I translate either vectors together, like here, where this is A, say this is B, this is B, or I move a vector to be right here, And then this angle is the same angle, which refers to this angle. This angle refers to the angle between the vectors when they're both initial point to initial point. So that is the dot product. The dot product, I don't know what it does. Don't ask me what it does. If you know physics, this looks awfully like FD cosine theta, so take that as you will. Say this is force, you're doing a force here, but the action, or wherever you're doing it at, is to this side. I guess that's the angle if like they're opposite side. Say this is the distance you're going, so d, and your force is here, then that would mean you're doing negative work because the angle between this is 180, right? And that's negative 1. So you're doing negative work because the distance, or wherever it's the object is moving or has the energy, and the force acting against it is opposite to it. Likewise, say it's like right here, say that's 30 degrees and that's the force. It's kind of like saying, this is saying, how close are they to pointing in the same direction? And let's multiply these two magnitudes for a given problem. Like in work, where you need to multiply force and distance for whatever reason. And so for the abstract reasons, a vector A and whatever D, F, I mean, just get it what you will. This just multiplying the things you have here, multiply their magnitudes, and this is a scalar. This is called a scalar product, so you'll get a number, not a vector. You just get a number. So you multiply the magnitudes of these two, and then get the angle. Now, there is another equation for this, which is equal to, say u is a 2D vector, or 2D vector, a and b. Where was I? Okay, so v vector equals cd, and this a dot b, I mean u dot b, would equal ac plus bd. Yeah, and if there was a third variable, then it'd be times, yeah, that's all. Based on this equation, it's just adding the components of each vector, multiply the respective components and add them to the other components. That's what it basically means. Applications or work, what is it what does it mean really? I don't know. Not tell me what it means. The closest definition I got is how close do they point in the same direction with their magnitudes multiplied as a factor. I don't know. But anyways, so let's just do a problem. We're not gonna do cross product today. Let's do a quick problem. Right. So we got a vector here called u. You got a vector here called b. You got a vector here called w. And this is an equilateral triangle. Whoa. and it's basically asking what's um what's the what is the let's see. Yeah, I don't even know what this question's even asking. Oh, dot product of U UV and UW. Alright, dot product. So let's do the easy one out here. UV. They're all also, by the way, U. Crap, that's bad. U equals V equals equals 1. Well, I mean, you kind of knew those all equal by the equalizer lines. So U dot V equals 1 times cosine theta. Find cosine theta. Well, uh, I don't think we need to know that 60 degrees for equilateral triangle, so yeah. And that's equal to 1/2. And then for this U and V, now you might mistakenly say this is the angle right here. Let's emphasize that. So, you may make the mistake and say that the dot product of UV and UW are the same, but they're not the same. Because this angle is not the correct angle. The correct angle would be from initial point to initial point. So say this is U, this is W, this W. Now, this angle earlier by the translated U, still there, 60 degrees. But now we have to find this angle as the actual cosine theta, and we can find that easily by making another like fake angle, fake line, and by whatever equality x geometry angle theorem, this is 60 degrees, and 60 plus something equals 180 here, so that's 120, and therefore this is also 120. And there you go. So same numbers as last time, but this time it's cosine 120, and that's equal to -1/2. And that makes sense because they're not even pointing the same way, so it's negative. There you go.